Integration by substitution. So with integration, there are so many different methods you can use, and none of them are wrong, and you can pick whatever you like. But this one is particularly handy because what it does is make a really difficult problem a lot easier. So what we do when we using substitution is we try to find the trickiest part and substitute something really simple for it. And that simple thing that is generally chosen is u. All right? So we have u instead of x. Okay, so there's a few things we have to do when we do it, so we have kind of like rules. So I'm going to look at this example first. If we are integrating x plus 1 and x minus 2 to the power of 4 dx. Now, it could take us a long time to multiply this out to integrate, all right? And there's no such thing as a product rule, quotient rule in integration. So what we do is we say, oh, well, let's just decide to make this a lot easier by saying that, so step 1, u equals x minus 2. All right? So our point now is that we've got to get rid of all the x's. They've got to all turn into u's. So our next problem is we need to make this into u's. So our second step is to take this part, all right? So we've said that this part here is the tricky part because it's got a power of 4. We're going to take this part and turn it into u's. So if u equals x minus 2, then u plus 2 equals x, so x plus 1 will equal u plus 2 plus 1, or u plus 3. Are you happy with that?
Yeah.
All right. So we're aiming for this. So first of all, we need to know what x is. So we rewrite this to find out what x is. So x becomes u plus 2 because we're adding it to the other side. So now this expression here, we want to get rid of the x out of. It becomes u plus 2 from that x and plus 1 from its original. All right, but we haven't finished there because we still got to do this part. All right, it's got a dx and we need it to have a du. So to get a du, what we have to do is differentiate. So we need to differentiate dx by du equals. So this is the x here, right? Wherever it is now, here. U plus 2. U plus 2 differentiates to 1. Right? Pretend it's an x. All right? 1. So therefore, du equals 1 dx, right? Dx times over this side, so really that 1 would be handier over here, to be honest. But what we're saying is that wherever there is a dx, we can now write du. So when we rewrite this, we get the integral of this thing here is going to be u plus 3. This thing here is going to be u to the power of 4, and this one is going to be du. So they're equivalent. Okay? Now when we integrate, we have to multiply out, but this is a whole lot easier to multiply out because it gets to be that. Right? And now we go 5. We don't differentiate. I've just been doing differentiation with my year 12s. We go u to the power of 6 divided by the nu. 3u to the power of 5 divided by the nu plus c. Yes? Okay. So now we haven't finished. We have integrated, but we need to come back to here and put u back in. So put your x back in. So what does x equal? X equals u plus 2. No, u equals x minus 2. So that u equals x minus 2 to the power of 6 over 6 plus 3x minus 2 to the power of 5 over 5 plus c.
Is dx and du always going to be equal to 1?
No.
So I've missed that, but how can we differentiate it?
So we were taking this x here and differentiating it. So we're differentiating the x equation with respect. So if that said 3u squared plus 4, for whatever reason, then dx would equal 3u squared plus 4 differentiated.
So we're differentiating x with respect to u to get du.
Yeah. So this differentiates to give 1. All right? All right, let's have a look at another one. So the other type of one that usually they ask this in is a quotient with a lovely square root. So x minus 1 over the square root of x plus 1 dx. All right, so we go through those steps. What's the yucky? The yucky is the thing with the power, and that's this x plus 1. All right, so we're going to make u equals x plus 1. What does x equal? X equals u minus 1. What does du by dx equal? It equals 1, meaning du equals dx. All right, so those are the 3 things you have to find before completely rewriting the top. So now the top says u minus 1 minus 1. So x is u minus 1 over the square root of u, du. That's what we're integrating. Right, now we've got just one thing on the bottom. We can use that rule about splitting it up. So we have u over the square root of u minus 2 over the square root of u du. We have to use our power rules. So u over a half is u to the power of a half, and 2u to the power of negative a half du. All right, now we're going to integrate. So you see the integration sign isn't there yet because we haven't integrated. So it still stays part of the problem. So when we integrate this, add 1 to the power, 3 over 2, divide by the new power, or multiply by the reciprocal. All right, minus 2 of, add 1 to the power, u to the half, divide by the reciprocal, whoopsie daisy, that should have 3, which means multiplied by 2 over 1 plus c. Yeah, well, we're dividing by a half, so we're multiplying by the reciprocal. All right, where did we get the minus 2? It just was here all the time. It comes from the x, which is u minus 1, minus 1. Okay, so now we've got that, which really nicely writes out to 2 over 3 u to the 3 over 2 minus 4 u to the half plus c. We now have to put our u back in again, and our u is equal to x plus 1. So the answer is that. Right, so it's simple. It simplifies it a lot, but there are a few steps you have to do, which include that whole idea of differentiating that thing. So we'll do one more that's a bit trickier.
Why did we do du over dx that time rather than dx over dt?
We were differentiating u, so it doesn't matter which way you go really.
Okay.
You can differentiate the u statement with respect to the x, which is what I did there, or you can differentiate the x statement with regards to the u. It's just that at the end you need to make sure you get them on the right side.
Is there anyone that's better?
No, well, this one actually is, because at the end of it you want to swap du for whatever.
Yes.
So one more. Am I okay to get rid of this? This one? Yep. So one more that's slightly uglier is, I might do that one too. Integral of sine square root of x over square root of x dx. What do you think you might make u? Awesome. We're going to make it the square root of x, not just x. All right? So if we make u the square root of x, what does that make x? Go on, you know. Good. U squared. So dx by du, I'm going to do this one because it looks nicer to differentiate. Dx by du equals u. 2u. So that means that where there's a dx, we're going to replace it with 2u du. All right? 2u, because there's 2u there. 2u du.
I know, I was just making fun of it.
Like it's a bit of a song going on. So now we have to rewrite this guy up here. So we've got the integral of sine u over u times 2 du. Now what's really nice about this is they just cancelled. So actually it's just 2 sine u du. So if we integrate sine, what do we get? Negative cos. So we've got negative 2 cos u plus c. Substitute back in again. So our answer is negative 2 cos square root of x plus c. Cool, huh? Now this is the point. Gonna get rid of this bit now. If you see this one in the exam, you go to your table and you think, oh, I can do this. And 90% of people write that the integration is sec x cos tan x or whatever it is in the table because they read it the wrong way, because they can see a tan and they think it works. But remember that there's no tan by itself sitting over this side, so we can't go backwards that way. In fact, this is not an easy one to integrate because before we start, we need to change it a bit. So if we change it to this, and we decide to make u, what's the annoying one? Good. U equals cos x. All right?
Why have we got, sorry, over here, why have we got u to the power of a half? Because isn't that u to the negative a half times by u?
Here?
No, back.
Here?
Yeah.
Because that's
U
a 1,
bracket
that's
u.
a negative a half, and that makes u to the power of a half.
Wait, how? U
By
power
index
1.
rules. Index rules say we subtract the powers. 1 minus a half.
You add the powers because it's negative a half and
There's no negative a half. If we have 6 to the power of 2 over 6 to the power of 3 over 2, we subtract those powers. 3 minus 2, 6 to the power of 1, right? This is a 1, this is a half. 1 minus half is a half.
Okay. Yeah.
So, if we do that, what is du by dx? Minus sine x, right? Differentiating, getting a bit complicated because we're muddling up differentiation and integration a bit. So du is equal to minus sine x dx. So we go back to here to rewrite. We've got a u here, all right? And instead of that dx and that sine, we're going to replace it with not even. So this is here. And that equals that. So it's a negative 1 on the top, du. Right, so we differentiated it and we got negative sine x. We put the dx over this side, all right? We want to swap out for that dx, but that dx is connected to sine x, so we're going to take all of that and make it du. But there's a negative hanging there, so we need that negative to be with the du. So it's gone in front to become negative 1. All right, so now we've just got that. So we integrate that. Integral of negative u to the negative 1 du. Tell me what it is. Good, well done. I was waiting for somebody to tell me it's u to the power of negative 2. And what's u? And that's why it's not very nice.